Yeah, so I guess I forgot about this, huh? Well, it's as good a time as ever to finish up the rest of the Prehistoric Planet episodes, so without further ado, let's get going. Prehistoric Planet is now officially fully out on Apple TV Plus for everyone to enjoy. This whole project was, according to Dr. Steve Brussati, about 10 years in the making. Precisely what that means in regard to exact start times, fundraising, and expert collecting all the way to the finished product is unknown. Surprisingly scant are references to the directors of the show, Andrew Jones and Adam Valdez. Aside from the artists doing all the hard hands-on work with the dinos and the paleontologists guiding their hands, the directors are the most important in regard to how the show is shot, how the animals are portrayed, and much more. The show is also produced by BBC Studios' Natural History Unit in conjunction with Jon Favreau of Iron Man, Chef, Lion King, The Mandalorian, and Jungle Book fame as executive producer and showrunner. The visual effects were done by the Moving Picture Company with narration by David Attenborough. The soundtrack was composed by Hans Zimmer, Kara Talv, and Hans Rosman. Talv and Rosman even invented and modded new instruments for the show in order to make some truly amazing sounds to mirror the truly amazing science going into this series.
And I also want to show you the Fat Rex that we use for our Velociraptor theme.
I don't think it is exaggerating to call Prehistoric Planet not just a successor to Walking with Dinosaurs, but a superior production aided by Hollywood money and cooperation among everyone involved. No one's expertise was thrown out by executive meddling or a director's personal preference. It would be a crime not to shout out the animators and CGI artists that worked on this project. Something Apple and BBC apparently couldn't spare the time to do with their credits. Shashank Shekhar is a texture and visual effects artist that worked on the project for 1.5 years, specifically working on the Velociraptors, Coorthoraptor, Therizinosaurus, Beelzebufo, Ornithomimus, and Troodonts. Another artist that went uncredited is Cameron Clow, who is a creature animator and pre-viz, post-viz artist for Marvel, HBO, and BBC. On top of that, he is a part-time animator for Prehistoric Kingdom, hence the quite lifelike movements. He worked on the Triceratops segment, as he has more expertise in the muscles, movement, and life appearance of these guys. Torosaurus is his favorite dinosaur after all. Sanjay Singh worked on some of the main animals, like the Tarbosaurus, Caesarosaurus, and more, with the Moving Picture Company. Alan Bolkas was also with the Moving Picture Company, with Damien Guy-Munoz and Anthony Sieben, and supervised by Dan Zelks. Michaela Dahl, who goes by Silvery Lantern on Twitter, and Sean Lack, or Momentarily Epic on Twitter, were also animators brought on board the team. I'm confident that I'm missing some people here, as this project was a monumental effort by a monumental team. Unfortunately, there is only so much I can do to find everyone involved when the show kinda made very little effort to highlight those same people, so I apologize to those I have left out. Unfortunately, the caveat for the whole series is that it only takes place 66 million years ago. However, it takes us all over the world to show us animals that the general audience has never seen before. It also has to show you animals you know, but thanks to 20 plus years of new information since Walking with Dinosaurs, these old favorites are refurbished to show the audience how much the hard science of paleontology has changed. It also doesn't take place precisely at 66 million years. It is stated to be 66 million years for simplification, but it takes place between 72 and 66 million years, just for clarification. These are the most accurate prehistoric animals ever to be recreated in video form. Each episode covers a biome across the planet rather than a chunk of time. It was a 5-night event with 5 episodes each coming out on each of those 5 nights. Recap. Our episode opens up in the darkness of winter, somewhere in the northern hemisphere. The camera tracks along a set of 2-toed footprints left in the snow before we cut to a sleeping dinosaur. This guy is a dromaeosaur, your average raptor dinosaurs. It is stated that this little guy has survived 3 months of near total darkness, and the episode pretty much begins as soon as spring starts. We see this little dromaeosaur run about for a little bit looking for something to eat and finds a beetle. Then we see 2 dromaeosaurs snuggle with each other before getting interrupted by a herd of Edmontosaurus. A small pack of dromaeosaurs form and hunt the herd. Once the herd reaches an icy river crossing, the dromaeosaurs take their chance and try to kill a juvenile who gets caught in the river and washed downstream. The mother follows and the baby heaves himself out of the river. The dromaeosaurs didn't kill anything, but they found a dead Edmontosaur anyway. We see the herd move on and we cut to the next segment. The next segment takes place downstream of the last, more northern region. Our main characters for this segment are a colony of male Ornithomimus building nests to attract mates. They scratch out craters in the sediment and cover it in sticks and leaves. Here is where we get to see competition between males to make the best nest. From there, we are whisked away to the next segment taking place in what is now Russia, or at least the part of Eurasia that is pretty damn close. The main characters here are a herd of Olorotitan and their quest to make nests, lay eggs, and have their babies in a northern volcanic region, as it is the warmest place during the colder winter. They reach their nesting grounds, do all the stuff they need to do, and we get to see a ridiculous time-lapse of them grazing across the freshly greened lawns of the volcanic field. Babies hatch, and we are treated to some of the cutest dinosaur babies so far in this series, even with a practical nest and eggs. The conflict of this segment comes at us fast as mosquitoes start reproducing and swarming in the area due to the warmth and water. They attack everyone, but their attacks are most severe for the babies. We even get a fake-out death of one of them. Fun stuff. From Russia, we are taken back to northern North America, probably Canada, to see what occurs when a forest fire happens. The main character here is a troodontid with no name, as he takes advantage of the forest fire to catch prey. Also, he may have started it, or at least is picking up bits of it and starting more fires to better catch some food. He gets a big fat mammal. And then we go to the next segment, which shows the summer season of the last segment change into autumn and then into a polar winter before swooping to Antarctica. The Antarctica segment is centered around hibernation and a small group of juvenile Antarctopelta who struggle to find some good and safe places to nap for months on end. One of the brothers is voted out of his brother's burrow, so he goes on a little journey. Coming across some reddish hadrosaurs, he finds a little cave off in the middle of nowhere that happens to have some glowworms living on the ceiling and takes the big nap. The next segment takes us back to northern North America to see what happens when the dinosaurs don't migrate for winter. Our main characters in this segment are the Pachyrhinosaurus and Nanuqsaurus and their battle for survival in the blizzards of winter. Some Pachyrhinosauruses fight each other, then a pack of Nanuqsaurus slow pursuit them until they can get them in the open and isolate one from the protective circle they have formed in the blizzard. They get one of them and have some chilled dinner. That was Ice Worlds. Tell me what your favorite segment is from this episode in the comment section below. Onward to the meat and potatoes, the reason you're here. Animal accuracies or not. The point of this whole endeavor was to show what the public knows as the main characters of the late Cretaceous, dinosaurs, pterosaurs, and the marine reptiles, in as natural and accurate a light as modern science and technology could make possible. to marry the groundbreaking technology produced for and used in the film industry to bring back the long dead with the help of cutting-edge dinosaur science. As such, every single critter should be as up-to-date as studies and fossils will allow, and any sort of soft tissue structure or behavior should be backed up with as much parsimony as possible. Has Prehistoric Planet succeeded in this venture? Well, in order to answer this question, we must first painstakingly approach each and every design with information from the literature, the fossil record, and from the very words of the scientists who were consulted for the project. Kirsten Formoso, Professor Steve Brussati, John Hutchinson, Robert Spicer, and Paul Valdez, Doctors Darren Naish, Mark Whitten, Victoria Arbour, Alexander Farnsworth, and Scott Hartman. Dinosaurs in ice? When we think about a time when dinosaurs ran the world, we often picture hot, humid places in a world that is vastly different from our own. But Prehistoric Planet, narrated by Sir David Attenborough, shows that dinosaurs lived and did well in many different kinds of places, including colder areas where snowstorms, freezing fog, and sea ice were typical. When the show's makers first asked Professor Bob Spicer and Alex Farnsworth, both meteorologists and paleoclimatologists, to help them figure out what the weather and environment were like for dinosaurs before they died out, about 66 million years ago, they had to solve a problem that has been around for decades in paleoclimate modeling. That is, when scientists use computers to simulate or model the temperature of prehistoric Earth, the models tended to make the poles much colder than the fossils and rocks showed they had been. Not only have the researchers made their models better for Prehistoric Planet, but they have also run the computer programs longer than anyone else has ever done to get the models as close as possible to ancient reality. The BBC's Natural History Unit, which was in charge of making the show, needed to know about the weather so that they could film in real-world places that looked like places where dinosaurs lived in the past. But most of what is known about the climate that long ago comes from indirect proxy evidence, like fossilized leaves and traces of certain chemicals in rocks, which can only be used to figure out the average climate over decades or centuries. This is where the assumption that the Cretaceous world was much hotter and had more water in it comes from. This inference isn't exactly wrong, but it doesn't tell the whole story, because weather, temperature, and climate behave differently. For example, even though the world is getting warmer, Texas, which is usually hot and muggy, can get a lot of snow. Geologists will notice the quick warming of the planet a million years from now, but not the freak snowstorms. Still, it's important to model what these snowstorms were like in the past because we know that warmer worlds will have more extreme weather, and these extremes will have been a big part of why some places were totally unlivable for dinosaurs. Even though fossils can tell us a lot about how the weather was in the past, most of them can't tell us what the weather was like day to day. So, how do we know what the weather was like on May 27th, 66 million years ago, in a certain place on Earth? To do this, the researchers needed to use a computer modeling of the climate, like the ones used now to predict how the climate will change in the future. These models are based on basic biological and physical processes that don't change over time, so the researchers can change them to fit past worlds, even if they don't know exact details like where the mountains were or how high they were, or how much carbon dioxide was in the air. Then they can use fossilized leaves, coral, or rocks, which have signs of what the climate was like at the time, to check how accurate these models are. If their model fits the proxies, which it did, they can be sure that it is simulating the weather as it would have been at the time. So, what did they learn from trying to figure out the weather 66 million years ago? Their models showed that there would have been strong blizzards in Antarctica, Category 6 hurricanes in the mid and low latitudes, which we are likely to see in our lifetimes, and large, always-present fog banks that made winters cloudy under polar cloud caps. This doesn't sound like a place where dinosaurs would be happy, but the old idea that dinosaurs were cold-blooded and needed warm weather to live has, for the most part, already been proven wrong. The new idea is that dinosaurs were warm-blooded and could control their body temperature in some ways, like mammals can today. This would be necessary to survive big changes in temperature caused by different weather trends, especially in the Arctic and Antarctic. So, the modeling backs up recent fossil finds that show that some dinosaur species were used to living in cold environments, could see in low light, which would have been helpful in those big fog banks, and thrived all year near the poles. The scenes of Prehistoric Planet with the cold pachyrhinosaurs were filmed in Alaska. This shows why the series wanted to use climate models to check how accurate it was. We know what it was like there 66 million years ago because of the fossils of plants, dinosaurs, and other animals. However, the old models said it would have been an extremely cold and lifeless tundra. Instead, the model agrees with the fossil evidence and projects forests all the way to the edge of the Arctic Ocean at 82 degrees north, which is much farther north than any trees are today. Dinosaur food would have been easy to find in the summer, but it would have been harder to find in the long, dark winters because fossils and computer models show that it was very foggy. Dinosaurs survived for 165 million years, which is a long time. Tyrannosaurus rex, for example, lived much closer to people than it did to Stegosaurus. They were able to survive for so long because they were strong and could change with the surroundings, just like mammals do today. The research for Prehistoric Planet shows that they were able to live through bigger temperature swings, stormier weather, and worse droughts than humans have ever seen, at least so far. Dromaeosaurus Design. Dromaeosaurus was the first of its evolutionary lineage to be discovered. There may have been bits and pieces of these dinosaurs found before Dromaeosaurus was found or named, but it was technically the first recognized by science. It's why its lineage was given its name after all. Despite being the first one named all the way back in 1922, it wasn't particularly reflective of an archetypical raptor or dromaeosaur. Its body was heavily built, having long, grasping foldable arms with supermobile fingers and claws, long digitigrade hind limbs ending in hyper-flexible toes and talons, a long, semi-rigid tail for counterbalance, and a long neck. However, it had a much shorter and more robust skull than many dromaeosaurs found after it, like Velociraptor. It was just a smidgen larger than Velociraptor and a touch more robust, but pretty much in the same size range. Its fossils have been found in Alberta and across some western US states. It's easily one of the most well understood of the dromaeosaurs. So, how did Prehistoric Planet do? Exceptionally well, as usual. The narration states that these little guys are dromaeosaurs proper. This is not that far out, as Dr. Naish has stated on Twitter. However, these snow-covered segments of the Ice Worlds episode technically take place in Alaska, where no Dromaeosaurus fossils have yet been found. That being said, Alaska isn't far enough away from Alberta to find this that much of a stretch. The Dromaeosauruses are decked out in a fashionable suit of white underbellies and a mix of grays, blues, greens, and grayish browns on top. From what I can see, the blues and greens seem to be a metallic sheen reflected by a dark pigmented base color. This is a type of coloring that many animals use called structural color. The microscopic outside layers of the feathers have little structures that absorb the light, bounce it around, refract it, and reflect it back out at different angles, causing a metallic reflective look that can have just about any color to it depending on the exact structures. Though I think it's also possible that the feathers on the dinosaur's tail are just blue, rather than refracting blue, as they don't seem to change color as the animal moves. Fun fact, true blue is super hard to make or evolve with pigments, so the majority of blue animals are using a special type of refractive structure to make blue. You can learn more about structural color in the second episode of Prehistoric Palettes. There is, as Darren notes, no doubts whatsoever that these animals were covered in feathers with plumage as complete as that of a modern bird. Some Chinese fossils of smaller and similarly sized dromaeosaurs show that raptors of cooler climates had feathers on their toes and fingers, as seen in most ice world inhabiting dinosaurs today. This is therefore reflected here in the polar dromaeosauruses. They are a lot fluffier than the velociraptors of Mongolia or the austroraptors of South America. The forearms of these Dromaeosauruses are fully decked out in all of the complex to semi-complex feathers we know the entire group had. A ton of Dromaeosaur specimens don't preserve their wing feathers, or any feathers for that matter. The vast majority of those that do are small and were uncovered in China, those being the gliding Microraptorines and the velociraptor-sized, ground-dwelling Zhenyuanlong. Plenty of theropods that are related to the true dromaeosaurs are found with simpler feathers, akin to those on emus, or even simpler ones that look like hair. Tyrannosaurs, Oviraptorosaurs, Therizinosaurs, Scansorioptergids, and then a bunch more advanced bird-like theropods such as troodonts, avialans, and true birds. There aren't any large-bodied members of the Eudromaeosaurian subgroup that contains the majority of the things we informally call raptors with feathers preserved yet. However, there is a single specimen of Velociraptor, or something very much like Velociraptor, that contains a series of notches on the arm bone. These notches are the same thing seen in birds, quill knobs. Their presence directly proves that the animal had feathers. The interpretation from this is that the majority of these animals had similarly complex wing feathers as Velociraptor and all other dromaeosaur relatives that did have wings preserved. Some have criticized the designers of the dromaeosaurs and Prehistoric Planet for continuing the complex vein feathers of the wings up the arm and onto the humerus or upper arm. As far as I can tell, this is not really the case. The feathers continue up the humerus, but not all the way, because there can't really be anything in the way of the armpit and the axis of rotation of the shoulder. The majority of the wing is composed of two major wings, the hand and the forearm. Some of the forearm wing continues for a bit around the elbow and up the humerus, but decreases in size quickly and does not continue to cover the entire humerus. The type of feathers on the humerus would have been the coverts and converts, but wouldn't have attached directly to the humerus bone. Instead, they may have been attached to the skin of the humerus. As with the velociraptors, the dromaeosauruses have a ring of thicker tissues around the margins of their mouths. This looks somewhat like a beak, but is likely composed of simple lip tissues, hardened skin, or partially keratinized skin. Easily the best dromaeosaurus ever put to film, barring any minuscule nitpicks that don't matter that some dromaeosaur experts might have. Behavior. The first time we see Dromaeosaurus in the Ice Worlds episode, we watch it wake up from a good night's sleep. It's stated that it is beginning to become spring-summer, and since the region is quite close to the North Pole, it experiences long periods of dark and long periods of light, just as it does today. Before the raptor wakes, it is in a curled position that is actually not entirely speculative. There are a handful of specimens of dromaeosaurs and close relatives that died in their sleep, and therefore preserved the sleeping posture. MacLeod, a small member of the Troodontidae, a lightly built family closely related to the dromaeosaurs, has two specimens preserved in a sleeping bird-like posture. There is apparently also a specimen of the troodontid Sinornithoides in the same posture. Paleontologist Riley Black noted all the way back in 2012 that there is even a specimen of the early coelophysid Segisaurus in somewhat of a similar posture, with its legs tucked underneath its body and arms folded in a resting posture. You may think that going over this very minute detail is superfluous, but extinct animals are almost never preserved in the same postures they had at the time of death. So finding a few so close to birds, and a few in such positions as to actually expand the understanding of dinosaur behavior is quite something. If you thought that was unnecessary, get ready for the next little bit of behavior the Dromaeosaurus does. After getting up from its sleep, the raptor scratches itself with its foot. There are two ways that birds can and do scratch themselves. One is when they bring their foot above their wing and do a little scritch-scritch. The second is when they bring their foot underneath their wing and do a little scritch-scritch. Crocodilians do the above-the-wing maneuver, though forelimb rather than wing, of course. So the Prehistoric Planet team had their little snow raptor do an underwing scratch. After waking up, our little dromaeosaur friend is hungry and goes looking for something to eat. As Dr. Naish makes clear, these animals were generalists that preyed on anything they could kill, including all manner of small critters like bugs, arachnids, mammals, baby dinosaurs, reptiles, turtles, crocs, fish, and amphibians. This is reinforced in Ice Worlds when the Dromaeosaurus somehow finds a non-frozen beetle scuttling around and nabs it as a pre-breakfast snack. The next bit of behavior we see with Dromaeosaurus in Ice Worlds is a pair meeting up and doing some bonding behaviors like touching and rubbing. This is something seen in pretty much every bird alive today and across most of the animal kingdom, so it would be super weird if dinosaurs never did this. However, there is no fossil evidence for this at all. Not entirely sure how there could be. The pair are alerted to an incoming herd of Edmontosaurus, and thus begins the final bit of behavior we see performed by the Dromaeosaurus. Pack hunting. Well, pack hunting of a kind. These predators were about the size of today's coyote, but with a stronger bite and far pointier claws. It's now hypothesized that these animals may not have been capable of coordinated pack hunting as in some unique social mammals alive today. They were still quite intelligent, but may have hunted more like some modern birds, such as Harris's hawk, a pair to a handful of related animals technically hunting together, but not in a super coordinated hierarchical structure. Komodo dragons do something similar, but even less cooperatively. This is the hypothesis shown in the Ice Worlds episode, as a pack of 3 raptors startle the Edmontosaurus herd in order to catch and kill a young individual or spook the herd into accidentally killing one of their own. This is what ends up happening as a juvenile Edmontosaurus drowns in the panic as the herd crosses an ice-covered river. The end of the segment has the pack finding the dead juvenile and going to work with their short, recurved teeth. Edmontosaurus Design. Edmontosaurus is probably one of the most well-known non-avian dinosaurs aside from Triceratops and Tyrannosaurus. It is one of the most common fossils across late Cretaceous North America, one of the most common hadrosaurs, and has such a long and tortuous taxonomic history that there are at least 8 genera and species erected to name the remains of the same Edmontosaurus over the course of about 100 years. Various fossils of what we now call Edmontosaurus were given names such as Agathaumas, Anatosaurus, Anatotitan, Clausaurus, Hadrosaurus, Thespesius, and Trachodon. Only a few of these genera would remain intact, with most becoming dubious as the majority of the fragmentary fossils given to them became assigned to Edmontosaurus. There are now 2 known species of Edmontosaurus, Edmontosaurus annectens, named in 1892 but given to the genus Clausaurus, and then Edmontosaurus regalis, the first use of the Edmontosaurus name in 1917. There are so many fossils of Edmontosaurus known, and so many keep eroding out of outcrops, that it's one of the few dinosaurs that no one really cares about private companies excavating and selling for profit. There are a handful of fossilized mummies of Edmontosaurus known, as well as specimens that were not mummified prior to fossilization, but preserved impressions of their soft tissues. Just for some food for thought, there are currently 22 skulls known for Edmontosaurus. Now, take into account how many other dinosaurs are known from non-skull bones, and assume that there are far more than 22 skeletal specimens with no noggins, also known to science, plus the tons and literal tons of fossils recovered every season by private and institution-affiliated dig crews, and you have yourself one of the most numerous dinosaurs ever. Even here, however, not everything is known or can be known about the animals. Did they all have the fleshy coxcomb of that one specimen of an Edmontosaurus regalis? Was that present in both sexes, only males, females? The Prehistoric Planet Edmontosaurus appears in Ice Worlds and Season 2's Swamps. The design is pretty much the same in both. The model is reused later on in Ice Worlds and seems to be remodeled into the Barsboldia model in Deserts. The Edmontosaurus has an off-white to grayish-white underbelly and what seems to be a dark gray to brownish top with reddish vertical patches down the neck and sides. The adult males have an iridescent bluish-green mask on the sides of the face and along the snout that the females lack. The juveniles seem to have the grayish top colors replaced by the reddish-brown colors. Paleoartists, like all artists, tend to have their own styles when it comes to how they recreate the extinct, and the Edmontosauruses are so very of Gabriel Huguetto's style that it is almost distracting. He was one of the paleoartists that worked on the show, so it's not a surprise, just interesting to point out. The Edmontosauruses of Prehistoric Planet are decked out in plenty of muscle and fat, as in modern living healthy animals. Their skin is made up of a pavement of small to medium polygonal scales, broken up now and again by much larger feature scales. Some of their skin also has bulging chicken or turkey-like lumps and scales. Along the backs of Prehistoric Planet's and Reality's Edmontosaurus was a ridge of short, laterally compressed, rectangular, subrectangular to triangular scutes. These have been lost in every Edmontosaurus specimen that doesn't preserve soft tissues, but are either present in the specimens with soft tissues or the spaces where they were are preserved. Most experts think all Edmontosauruses had these scutes. The Prehistoric Planet Edmontosaurus Design uses new information about the feet found thanks to the continued work on the fossil mummy known as Dakota. Found in 1999 by then high school student Tyler Leeson, Dakota would not be fully investigated until 2004, when Leeson discovered the soft tissue preservation of the find along with British paleontologist Dr. Phil Manning. The find would be fully excavated in the following years, CT scanned with NASA and Boeing scanners, and described. It would receive further preparation over the following almost 20 years, with a new discovery made in the early 2020s when the forelimb was fully excavated from the rock that still encased the specimen. In a 2022 paper, Stephanie Drumheller, Clint Boyd, Becker Barnes, and Mindy Householder described the foot and the fossil processes that allowed Dakota to become as well preserved as it was before fossilization. These guys were walking on the second, third, and fourth fingers that were encased in a fleshy mitten like a hoof of sorts. On the outside and front of the foot was a large hoof-like nail that likely did not contact the ground. The second finger seems to have had a spade-shaped claw sticking out to the side. The fifth finger was not included in the mitten and may have been something like a dew claw or was encased in the hand higher up. This whole configuration is reflected relatively well in the Prehistoric Planet Edmontosaurus, as well as every other hadrosaur that appears in the show. Another interesting bit of anatomy is something I've already covered in my video, Duck-billed dinosaurs aren't duck-billed. In short, some hadrosaur carcasses have bits of what looks like keratinous beak material preserved on their faces. Turns out that these bits of tissue are most likely sediment that filled in the mouth and backside of the beak of the upper jaw after death. The keratin that covered the beak decayed away and left behind an impression of the backside and the extent of the beak on the actual jaw bones. This is seen in this Edmontosaurus specimen on display at the Los Angeles Museum of Natural History. This means that the beaks of these animals were almost like giant mustaches that hung down from the upper jaw to completely enclose the lower jaw's tip and form a better shearing contact surface. This is reflected in Prehistoric Planet's hadrosaurs and Edmontosaurus. Behavior. The Edmontosaurus is shown to be a herd animal. This is backed up by too much evidence and data to explain in detail. In short, extensive bone beds are known of this animal, with groups of them at various ages as well. 3 quarries containing Edmontosaurus remains are identified in a 2007 database of fossil bone beds from Alberta, South Dakota, and Wyoming. On top of that, nests, eggs, nestlings, and hatchlings are known from various sites across northern North America and into the polar regions, including Alaska. This has been interpreted to mean that not only were these animals gregarious herd dwellers, but that they mostly did not migrate. How could they migrate if they were having babies and raising them in nests in areas as far north and chilly as Alaska? Instead, the narration calls the Edmontosaurs nomads. Nomads in that they are constantly on the move for new food sources, not that they migrate across huge regions of the continent. Speaking of babies, Edmontosaurus was like most other dinosaurs of its size and family group in that they laid 20 to 30 eggs per clutch in huge round nests dug into the earth. They brought plant material to the nests to cover the eggs. That plant stuff would decay and produce heat that would help keep the eggs at the right temperature. These dino mamas were way too big to sit on their eggs. There is even evidence for this in fossilized egg sites, most notably from the close relative Maiasaura, but also some Edmontosaurs too, that have fossil plant material preserved with the eggs and mounds. The hadrosaurs used a reproductive strategy that was somewhat of a mix between what is scientifically known as R and K selection. R selection animals are those that put the littlest number of resources into raising their young, but put a lot more into the amount of young. These are your turtles, frogs, and mice. The opposite are K selection animals, which produce few offspring that they put a lot of care into. These are your elephants, whales, and, well, us. Hadrosaurs did a mix in that they did produce quite a lot of offspring up front and gave them some moderate care until they could stand, walk, and leave the nest, upon which the care was lessened until the offspring were big, had their numbers reduced, and could tag along with the herd. This is sort of what is seen in alligators today. In the Edmontosaurus segment of the Ice Worlds episode, we see that one of the juveniles gets carried away by the ice river current, and the mother gets panicked and tries to save her baby, or at least make sure she does not lose it. The juvenile is able to get to shore and reunites, but we don't exactly see her jump in or grab her baby like we might see with elephants. We see the Edmontosaurus again later in the episode with the Ornithomimus herd, but they don't do much and are more so background animals. They appear again in the Swamps episode of Season 2, but I will save any commentary for when I get to it. Ornithomimus Design. Ornithomimus, the bird mimic, like most things named slightly before, during, and slightly after the period in American paleontology known as the Bone Wars, has a long and storied history. It was named by Othniel Charles Marsh all the way back in 1890, based on a partial leg and arm that were found a year or so earlier. Over the next few decades, up to 6 or more species were named of Ornithomimus based on various fossils at various stages of preservation and from various regions of North America. Some species were sunk back into the originals, some were found to be unique genera like Struthiomimus, and others were found to belong to tyrannosaurs. The Ornithomimus in Prehistoric Planet considers everything that is known about Ornithomimosaurs in general, as well as a few interesting and recent developments about Ornithomimus specifically. One may wonder how confident any scientist can be about how feathered these animals were. Before any direct fossil evidence of feather impressions are, or in this case were, found, one could have used the science and art of phylogenetic bracketing to assume that the entire Ornithomimid group had feathers as an ancestral trait. That is, all of the theropod groups that are on either side of the ostrich dinosaurs on every evolutionary tree ever made have at least one piece of direct proof of feathers. If this is true, and it is, then it is safe to infer that this feature was likely present in the common ancestor that all of these groups shared, and that maybe some lost feathers along the way. I am, of course, talking about the long and Neutyrannus of the Tyrannosauroids, Sinosauropteryx of the Compsognathids, the unplaceable Giravenator, Bapiausaurs of the Therizinosaurids, a possible Alvarezsaur, and too many Oviraptorosaurs and Dromaeosaurs to count. Semi-recently, the giant, heavily built, humpbacked, spoon-billed Nanuqsaurus was found to have a fused bit of vertebrae at the end of its tail that resembled something of the pygostyle seen in birds. If this is a pygostyle, then that may indicate it had a frond of feathers at the end of the tail, as in many dromaeosaurs. The Spanish Pelecanimimus may also preserve feather impressions, but some have debated if they are actually the remains of collagen fibers. But then, more than one example of direct fossil evidence was found for Ornithomimus specifically. A 1995 specimen was found with quill knobs on the arms. As you may recall from my many screeds about dromaeosaurs, quill knobs are direct evidence that feathers were present and hooked up to those knobs. If the knobs are missing, that doesn't mean the animal didn't have feathers, as many birds today may be found without the knobs. A 2008 and 2009 discovery of several Ornithomimus skeletons was made. These guys preserve direct impressions of feathers on their bodies. Another feathered specimen was found and then described in 2015. All told, they show that Ornithomimus was covered from head to toe in what are called plumulaceous feathers. These are feathers that are sort of like downy feathers or the simple downy dino fuzz of some dinosaurs, but are a little more complex, like flight feathers. They are the type of big poofy things you see on ostriches, emus, and cassowaries. Not quite loose enough to be down, not quite tight enough to be what is called pinnaceous. Pinnaceous feathers are more complex and organized like flight feathers and were found on the arms of the adult specimen. The juvenile only had plumulaceous feathers on its body and no arm feathers. It's been hypothesized that this means the wings are a thing that appeared during sexual maturity and may have therefore been a sexually selected trait, aka the bird mimics thought arm wings were sexy. Also of note is that the fourth specimen preserved skin impressions as well, which showed that halfway down the thigh to the rest of the leg was bare skin like ostriches. Also of note is that some researchers think that the wing feathers cannot confidently be called pinnaceous and may have just been plumulaceous like the wings of emus. That was a lot to go through to tell you that Prehistoric Planet's Ornithomimus, like pretty much every animal in the show, is the most accurate and up-to-date reconstruction of it ever. The ones in the show have a brownish-gray skin tone with light gray to slate gray feathers on the body, tail, arms, and neck. They have a dark grayish-black faux hawk of feathers on their heads, not unlike that of the handsome visage of Gabriel Igueto, one of the paleo artists that worked on the dinosaurs in the show. Curious that. The males also have huge scarlet-trimmed wings that are inferred to be a sexually mature trait, as the main young male character of the segment has just gotten his. These critters even have feathery eyelashes, like most birds do today. Behavior. In the Ice Worlds episode of Prehistoric Planet, we get to know the Ornithomimus through a segment about their nesting behaviors. These animals are presented here similarly to what is seen in lekking bird behaviors as well as Gentoo penguins, but is also generalized a little bit based on known dinosaur nesting behaviors. In the episode, the Ornithomimus males are gathered together making up their own nests as a sort of stage 1 structure to impress the females enough to mate and then make the nest even better. Essentially nothing is known of the true nesting behaviors of the Ornithomimosaurs, as no nests have yet been found, so the team inferred the crater-shaped, above-ground, base-sculpted nests filled with rotting veggies for incubation from the behavior of alligators, some birds, and direct evidence from other dinosaur groups. These hypothetical but educated guesses for Ornithomimosaur nesting habits therefore requires a lot of building materials, providing a perfect mate attraction technique for the experts to work in and to teach the viewer about. The males compile the foundations for the nests and then help the female to construct the final product. As Dr. Nash noted on Twitter, the non-avian dinosaurs seem to have been largely egalitarian. Both males and females seem to be roughly similar in size, with similarly elaborate crests, horns, and spikes. It was once thought that there should be sexual dimorphism in the crests of dinosaurs, as seen in most animals. However, there are some crested dinosaurs known from so many specimens that all have the same crests. If it was a strongly sexually dimorphic feature, then there should be obvious differences among those specimens sampled. There may also be evidence that males specifically contributed to nesting and nest care. In December of 2008, a study found that male theropod dinosaurs did most of the work of caring for the eggs in their nests. Dr. David Varicchio of Montana State University and his colleagues looked at the fossil nests of 3 late Cretaceous theropod dinosaurs, Citipati, Oviraptor, and Troodon formosus. The team used a variety of methods to conclude that, like 90% of the living bird species today, male theropods did most of the parenting work. The conclusions were reached after examining fossils for evidence of bone cavities associated with the loss of calcium from the body in order to produce eggshell. These cavities are called medullary cavities, and in them were stores of calcium. Such cavities would be expected to be seen only in females. Since none of the fossil bones showed such cavities, it was suggested that the individual dinosaurs found in close proximity to a nest of their own species were most likely male. The number of eggs laid per nest compared to the body size of the adult dinosaur supported this view as well. The study proposed that theropod dinosaurs produced unusually large numbers of eggs per nest for their body size. This pattern is often seen in living birds, when the male alone takes on the parental duties. The female can afford to lay more eggs, as she will not be looking after them, so she can be away from her maternal duties and get back to feeding herself up to replenish lost reserves in her body. So, it was concluded that the theropod males brooded the nest and probably played a significant role in looking after the hatchlings. But in 2013, experts from the University of Lincoln looked at the data used in the 2008 study and came to a different conclusion about what the fossils mean. With only the broken fossil record to go on, it's hard to figure out behavior, especially something as involved as parenting. Several things that are known to affect egg and clutch sizes in living bird species were not considered in the 2008 study. A newer scaling analysis of the number of eggs in a bird's nest showed that it might not be possible to tell what kind of care the parents give. Even though most experts agree that non-bird theropods and birds evolved from the same group of animals, that doesn't mean that they raised their young in the same or similar ways. The parents would act very differently depending on whether the hatchlings were precocial, young that are already independent, or altricial, young that still need their parents. The 2013 study found it interesting that most theropods seemed to show precociousness, which is when hatchlings are born relatively grown and somewhat independent from their parents. It's possible that the male theropod dinosaurs weren't such good parents after all. Before trying to figure out how adult theropods acted around their nests, Dr. Charles Deeming of the School of Life Sciences and his colleagues at Lincoln University pointed out a number of things that needed to be considered. Dr. Deeming is an expert on how birds and reptiles have babies. Because of this, he is in a good position to compare ancient animals with their living descendants. For example, some bird species intentionally put their eggs in the nest of another bird, so they don't have to be parents at all. This will change the size of some nests, which is probably how theropod dinosaurs acted too. When it comes to getting other people to do your work, there are some natural benefits. Dr. Deeming and his team looked at the statistics in a different way. They counted the number of eggs in all of the ancient nests of the theropod species that were part of the original study. Then, they figured out what the average number of eggs in a clutch was for each species. Dr. Varicchio and the researchers from Montana State University did their math based on the biggest number of eggs laid by each dinosaur type. When the British team compared their average numbers to the body mass of adult dinosaurs, they found that theropod dinosaurs were not in the group of males that only raise their own young. This does not, however, entirely rule out the male brooding hypotheses, so showing it once here in Ornithomimus is not scientifically inaccurate, but showing a speculative alternative or perhaps something that only some groups of dinosaurs practice. In the show, our hero male is shown stealing better sticks from rivals' nests, a good strategy that doesn't particularly pay off for him. Olorotitan Design. After the Ornithomimus segment of the Ice Worlds episode, we get to see a completely different type of hadrosaur than the Edmontosaurus of the beginning of the episode, the Russian Lambeosaurine Olorotitan. The Olorotitan was named and described back in 2003 based on remains found between 1999 and 2001 in the Amur region of Russia. It's technically the most complete Lambeosaurine skeleton known outside of North America and would have been a robust animal with the usual hadrosaur frame but with a big rectangular flag-shaped crest on its head and a laterally compressed face that expanded quite cartoonishly into that mustache of a beak. Prehistoric Planet's Olorotitan is decked out in a brownish-tan underbelly with a leopard-like network of dark brownish-gray connected stripes. There are splotches of bright blue that may have a little bit of iridescence to them on the crest. These hadrosaurs are decked out in the ridge of scutes along the back, as seen in Edmontosaurus. This is because this ridge is seen across a number of hadrosaurs outside of Edmontosaurus and in both the Saurolophine and Lambeosaurine groups of hadrosaurs. The hands of Olorotitan have been reconstructed in a similar way to the Edmontosaurus, based on newly prepared and described soft tissue preserving hands from Dakota, the Edmontosaurus mummy. Found in 1999 by then high school student Tyler Leeson, Dakota would not be fully investigated until 2004, when Leeson discovered the soft tissue preservation of the find along with British paleontologist Dr. Phil Manning. The find would be fully excavated in the following years, CT scanned with NASA and Boeing scanners, and described. It would receive further preparation over the following almost 20 years, with a new discovery made in the early 2020s when the forelimb was fully excavated from the rock that still encased the specimen. In a 2022 paper, Stephanie Drumheller, Clint Boyd, Becker Barnes, and Mindy Householder described the foot and the fossil processes that allowed Dakota to become as well preserved as it was before fossilization. These guys were walking on the second, third, and fourth fingers that were encased in a fleshy mitten like a hoof of sorts. On the outside and front of the foot was a large hoof-like nail that likely did not contact the ground. The second finger seems to have had a spade-shaped claw sticking out to the side. The fifth finger was not included in the mitten and may have been something like a dew claw or was encased in the hand higher up. This whole configuration is reflected relatively well in the Prehistoric Planet Olorotitan and Edmontosaurus, as well as every other hadrosaur that appears in the show. Another interesting bit of anatomy is something I've already covered in my video Duck-billed Dinosaurs Aren't Duck-billed. In short, some hadrosaur carcasses have bits of what looks like keratinous beak material preserved on their faces. Turns out that these bits of tissue are most likely sediment that filled in the mouth and backside of the beak of the upper jaw after death. The keratin that covered the beak decayed away and left behind an impression of the backside and the extent of the beak on the actual jaw bones. This is seen in this Edmontosaurus specimen on display at the Los Angeles Museum of Natural History, as well as a Ornithosaurus specimen. This means that the beaks of these animals were almost like giant mustaches that hung down from the upper jaw to completely enclose the lower jaw's tip and form a better shearing contact surface. This is reflected in Prehistoric Planet's Olorotitan. Behavior. Unfortunately, there is only one specimen of Olorotitan known to science, so absolutely no behavior can be inferred from any direct fossil evidence. However, the Prehistoric Kingdom team got to work referencing other hadrosaurs that have had behavior preserved in the fossil record. A substantial amount is known about the reproduction and nesting strategies of hadrosaurs in general, mostly because of fossil nest sites from Hypacrosaurus and Maiasaura. These sites confirm that most hadrosaurs were likely colonial nesters and revisited the same nesting locations year after year and across decades, and maybe even centuries. There have been dinosaur nesting sites made up of multiple thin layers of rocks, so it's possible these places were visited over very long periods of time. Prehistoric Planet shows the Olorotitan arriving at a location where old nests were already made. These nests are giant, crater-shaped structures excavated by the animal's snouts and feet. The Olorotitan have to tidy them up a bit and add new foliage before laying and incubating their eggs. Ice Worlds also shows Olorotitan to utilize natural geothermal areas to increase the ambient temperatures at which their eggs incubate. There is direct evidence of this type of behavior in sauropod dinosaurs at a fossil nest site in Argentina that would have been in the same area that ancient geothermal vents were. If the sauropods could do this, why not other dinosaurs? This is shown here with Olorotitan because their region, the Russian Far East region of Northeast Asia, had what is called the Okhotsk-Chukotka volcanogenic belt, which was one of the most active volcanic areas of the Cretaceous world. This belt covered a good 2,000 miles or 3,200 kilometers and was essentially all volcanic and plutonic material. There was large swaths of volcanism, but the area that the Olorotitan visit is more geothermal and less lava wasteland. That would be saved for the Badlands of Season 2. Another aspect of this segment of Ice Worlds is the timetable of hadrosaur growth. There are so many hadrosaur specimens across the handful of fossil nest sites that entire growth series from embryo to adult are known. This also allowed past researchers to plot how these animals grew over time. Incubation of hadrosaurs seems to have been quite quick at 3 to 6 months, meaning that the Olorotitan could lay their eggs in spring and take advantage of the 24-hour daylight and verdant plant growth that would occur throughout late summer, autumn, and maybe even into early winter as well. The fossil evidence suggests these dinosaurs took moderate care of their babies for a few weeks after they hatched. The parents would bring back food for them to help them get big and strong. In ice worlds, the Olorotitan are shown eating and bringing back horsetails to fuel the hatchlings' growth. Horsetails are considered superfood for the animals that can digest them and would have supercharged the growth of these baby hadrosaurs. Baby hadrosaurs grew quickly and died young. From a sample of 50 individual Maiasaura tibiae found at Egg Mountain, the massive fossil nesting site in Montana, it was found that these dinosaurs had a mortality rate of about 89.9% in their first year of life. If the animals survived their second year, their mortality rate would drop to 12.7%. The animals would spend their next 6 years maturing and growing. Sexual maturity was found to occur in their third year, while skeletal maturity was attained at 8 years of age. In their 8th year and beyond, the mortality rate for Maiasaura would spike back to around 44.4%. A few months of rapid feeding for the juveniles would have given them enough weight and size to leave the nests and follow the adult herd off to wherever they are for the remainder of the year. In ice worlds, the Prehistoric Planet team have the babies bothered by huge swarms of mosquitoes. Despite the impossibility of dino DNA surviving in a mosquito's gut for millions of years, mosquitoes are still known from the time of the dinosaurs. Insects don't fossilize well due to a lack of bones and a generally softer exoskeleton than most mineralized bones. Sometimes they are preserved in special places or substances, but not often. The oldest known mosquito fossil comes from Burmese amber dating to the late Cretaceous epoch, about 99 million years ago. This more than adequately places the insects in the time span of the Olorotitan segment, but some researchers have used molecular estimates that found the mosquito lineage goes all the way back to at least 197.5 million years ago, in the early Jurassic. In today's world, there are plenty of areas where mosquitoes can become such a nuisance that it forces groups of animals to leave the area, which is what is replicated here in ice worlds. It would be cool if baby animals in this show could go 5 minutes without harassment. Troodont Design. The taxonomic history of North American troodontid dinosaurs has been in flux since they were first named. The original Troodon, Formosus, was named in 1856 based on teeth. This is a now frowned upon practice, as with dinosaurs, one cannot fully determine species or genera from teeth alone. Caution flown to the wind a bit led to a slew of more complete skeletal remains being referred to Troodon, resulting in the classic super smart giant-eyed handsy raptor-taloned theropod we all know and love. Some more specimens were named Nanuqsaurus inequalis in the 1930s. Some more bits were given the name Polyodontosaurus grandis. Phil Curry's work in the late 1980s is largely responsible for most of us growing up on hearing only Troodon. He synonymized Polyodontosaurus, Nanuqsaurus, Pectinodon, and Troodon together, as it was thought that their differences were really indicative of differences in stages of growth rather than species. Paleoartist and researcher Gregory S. Paul did what old Paul does and threw in Sauroornithoides of Mongolia, but that didn't stick. What also didn't stick was the combination Curry did. Recent research has found that the original material used to define Troodon formosus was not up to scientific muster, making the genus and species itself a dubious one. All diagnostic material in the Troodon genus belonged to distinct genera and species. Nanuqsaurus was resurrected to hold a bunch of Albertan fossils, and a bunch more were used to define a new genus and species, the rather large Latenivenatrix mcmasterae. There is yet another unnamed giant troodontid from Cretaceous Alaska, known for now only as the Alaskan troodont. This mystery genus makes up 2/3 of the dinosaur specimens recovered from the Prince Creek Formation, which is unusual as troodontids are much rarer members of the fauna in other rock layers of similar times. So, what is the troodont seen in ice worlds? Dr. Naish has noted that he and his team variously went for Troodon, Stenonychosaurus, and Latenivenatrix over the development of the show, but ultimately decided to go for the generic Troodont name. Dr. Naish says this thing is human-sized. The segment is in a cooler forest in the Ice World episode that also contains segments that take place in Alaska, so it might be safe to assume this thing is based more on the Alaskan Troodont than any other Troodonts, besides maybe Latenivenatrix. The Troodont dinosaurs were technically not dromaeosaurs or raptors. Instead, they were their closest relatives. As their closest relatives, they shared a lot of similar traits, like a bird-like pointed skull, long skinny neck, huge arms with grasping hands, and giant pennaceous wings, long skinny legs ending in mobile feet with killer claws, and a long counterbalancing tail with a veined feather fan at the end. Compared to the most well-known group of dromaeosaurs, the Eudromaeosaurs, the Troodonts were more lightly built, with longer, skinnier legs, more gracile feet and claws, and skinnier snouts. There were many exceptions, however, especially as you get to the big ones. The wings and feathers present in Prehistoric Planet's Troodon are lifted from what is known of dromaeosaur and bird feathers, plus Troodonts have been preserved with feather impressions. The Troodont is decked out in a white underbelly, black mask, and light bluish-gray to dark ashen-gray top. It also has a funny little poof of display feathers on the back of its head, like the secretary bird. Behavior. Prehistoric Planet's Troodon is used to teach the viewer about a unique behavior seen in some modern birds of prey, pyromania. The segment begins at the start of a forest fire in some northern forest. Attenborough says that most animals flee the flame, but that the fire creates opportunities for some animals. We see the theropod get close to the edge of the fire to look for some food, and it grabs a burning ember from the fire in its mouth and carries it a bit before dropping it somewhere else, where it starts a new fire. The Troodont uses the fire it just started to flush out some multituberculate mammals, catches one, and then gets the hell out of the fire. Abundant fossil charcoal deposits show that forest fires were ubiquitous throughout the Cretaceous, in part due to slightly higher atmospheric carbon and higher temperatures, but perhaps also due to more dynamic storms than we see today. Dinosaurs would have therefore been quite capable of staying away from fires and understood what they meant. The stratigraphic pyromania shown by the Troodont is based on behavior reported in several birds of prey in northern Australia. They have been observed picking up embers and creating new fires to draw prey where they want them. The exact level of intelligence, or even sapience, of the smartest Troodontids cannot be known for sure, so one cannot so easily assume they were as intelligent as modern raptors, and could do the same things they could. However, one shouldn't discount the intelligence of these dinosaurs either, because some animals today that are considered stupid continue to shock us with intelligence or novel behaviors. The creators and scientists behind Prehistoric Planet wanted to illustrate how dinosaurs may have surprised us, and illustrate this interesting piece of archosaur behavior we see today. Multituberculate Design. In the forest fire segment of Ice Worlds, the super smart pyromaniac Troodont catches himself a little mammal that belongs to a grand order called the Multituberculata. This group of mammals were largely rodent-like, but with a bunch of other unique body types, and lasted from the Middle Jurassic to the Paleocene, with a North American, European, Asian, Australian, and Madagascan range, with the possibility of a South American presence as well, with the Ferugliotheriidae family. They are characterized by a set of chompers convergently resembling those of rodents, with huge chisel-like front teeth, a toothless space, and cheek teeth. The cheek teeth were often one or a few huge giant things with multiple cusps, hence the group's name. The critter in Ice Worlds is based on Cimolodon, which, surprise surprise, has about 5 species from the late Cretaceous of North America, but across a huge swath of it: Alberta, New Mexico, Wyoming, Utah, Montana, South Dakota, Idaho, and Alaska. That makes the one we see in Ice Worlds either a Canadian or Alaskan form. As far as I can find, this is the first time it has ever been put to screen. As far as I can find, and it's limited, Samolodon is not known from a lot of skeletal material, so its appearance is filled in based on close relatives with better specimens, like Meniscoesis of Cretaceous North America, and a bunch of Asian forms like Buginbatar, Cryptobatar, Dejoctotherium, and Catopsbatar. So here it is reconstructed like a cross between a beaver and a marmot, with a long bushy tail, brown and orange fur, a short robust head, and little grabby paws. Behavior. It gets flushed out of hiding and promptly eaten. What more do you want from me? An ice-free Antarctica? The second to last segment of Ice Worlds takes us to Antarctica, the great ice island at the bottom of the world. Back in the Cretaceous, it wasn't covered in the ice it is today, and was instead quite lush. Antarctica was ice-free during the Cretaceous period from 145 to 66 million years ago. During this time period, there were forests at both poles. Fossils of trees and cold-blooded reptiles have allowed scientists to build up a picture of what the climate was like. Cold-blooded reptiles need the warmth of the sun to survive. Today, we see them basking in the sun to warm up during the day. At the poles, where the sun disappears during the winter months, it must have been warm enough for them to survive through the darkness. The mid-Cretaceous period was one of the warmest intervals of the past 140 million years, driven by atmospheric carbon dioxide levels of around 1,000 parts per million by volume. In the near absence of proximal geological records from south of the Antarctic Circle, it is disputed whether polar ice could exist under such environmental conditions. A 2020 Nature paper, published by an enormous team of researchers led by Johan Klages, used a sedimentary rock sequence within a rock core to show that a temperate lowland rainforest environment existed at a paleolatitude of about 82 degrees south during the Turonian to Santonian ages, 92 to 83 million years ago. Klages said that the core sample is definitely the southernmost Cretaceous evidence ever recovered on the planet. The core Klages and his team extracted was taken from seafloor in West Antarctica, approximately 560 miles away from the South Pole. Inside the roughly 10-foot-long core, extracted in 2017, Klages and his team discovered a fossilized root network from the ancient temperate rainforest. The yellow strata of the core sample represent sandstone, and green is the intertwined root network of the ancient rainforest. Klages says that the heavily connected root network is pristinely preserved and is, more or less, indistinguishable from one you'd find if you were to drill into modern-day forest ground. On top of the pristine root network, the core sample also contains fossilized pollen and spores from the same period of time, which helps to clarify parameters of the Antarctic environment during the mid-Cretaceous even further. Klages says the mean temperature of this environment was probably on par with northern Italy and would have been an ideal location for insects and dinosaurs. Due to polar night, the phenomenon that sees the northernmost and southernmost regions of Earth plunged into darkness for months at a time thanks to the tilt of Earth's axis, keeping the sun below the horizon for more than 24 hours at a time, this ancient rainforest also somehow thrived for long stretches without the warmth and energy that the rainforests of today receive. As far as how a rainforest was able to survive in an area now frigid and covered in ice, that's all about our good old frenemy, CO2. According to the paper, for an environment like this to arise at this latitude, there must have been 1,120 to 1,680 parts per million of CO2 in the atmosphere. For reference, there are just over 400 parts per million of CO2 in our current atmosphere. That number is obviously rising thanks to human-driven climate change. A climate model simulation generated by Klages and his team show that this environment would have only been possible with that exceptionally high amount of CO2 in the air, as well as a vegetated surface, however. Meaning that even if we took those super high CO2 levels and applied them to our modern world's environment, it still wouldn't heat up to those mid-Cretaceous temperatures thanks to our ice sheets and the fact that they reflect sunlight and hence heat from the Earth's surface. All of the more reason to keep our ever-endangered ice sheets intact for as long as possible. Scientists also used the shells of fossil organisms that lived in the ocean, called foraminiferans, to understand past climate. By analyzing the chemistry of their shells and knowing the age intervals when different species lived, they can get an estimate of ocean water temperature during that time. Dr. Brian Huber from the Smithsonian Museum of Natural History investigates the Cretaceous with a particular focus on deep-sea sites around Antarctica. He explains, Foraminifera provides some of the best records because you've got both bottom-dwelling ones living in the sediments and recording bottom ocean temperatures, and then you've got the planktonic ones that live in the top 50 meters of the ocean recording atmospheric temperatures. When you couple those records through time and analyze the shells from different parts of the ocean all over the world, you get a really good idea of the evolution of climate. Huber elaborates that what they found in the Southern Ocean around Antarctica was hard to believe at first because it just seemed too warm. We found temperatures of 30 degrees C at 58 degrees south, close to the Antarctic Circle. These high temperatures occurred during the middle of the Cretaceous, known as the Cretaceous hothouse, a hot greenhouse effect caused by increased carbon dioxide in the atmosphere. But what happened in the Cretaceous to create a world where there were trees and dinosaurs roaming Antarctica, unlike the barren ice fields of today? Huber explains, what we know about the mid-Cretaceous in particular is that we had much faster rates of seafloor spreading and so much more volcanic sources of CO2. Huber and colleagues are still investigating whether the hothouse occurred as a result of a major amount of volcanism erupting CO2 and creating a greenhouse blanket that warmed the Earth, a perfect place for dinosaurs, hibernation, and occasionally cool temperatures during the shadows of winter. Antarctopelta Design. The first dinosaur fossils to ever be found in Antarctica belong to a small, mysterious, and fragmentary armored dinosaur found in 1986 and named and defined in 2006 as Antarctopelta oliveroi. Despite being the first found, it was not the first named. That honor goes to the early Jurassic Cryolophosaurus. There is only one known specimen that is a 15% complete skeleton, including some teeth, a chunk of jaw, some isolated skull bones, some backbones from the neck, back, hips, and tail, some bits of the legs, and a handful of osteodermal armor. That is not enough to get a great idea of how the animal looked when it was alive. When it was first described, the missing bits were filled in with better-known relatives. The problem here was that the animal was quite primitive compared to the rest of the ankylosaurs, with some analyses showing it as a primitive notosaurid or at a primitive but unplaceable position among the first ankylosaurs. This, coupled with the newly acquired information on ankylosaurs' soft tissues from various dinosaur mummies, helped the Prehistoric Planet team construct their juvenile Antarctopeltas. These guys are, in my opinion, decked out in some of the blandest color schemes in the entire show. They are a reddish shade of brown with what seems to be a lighter, yellowier shade on their undersides. Most of their anatomy is filled in with notosaur features, so their skulls are wide and their jaws are narrow. They have moderately long necks, not so stubby limbs, and moderately keeled armor along the neck, shoulders, back, hips, and tail. Their tails don't end in a club, as clubs are a feature of the ankylosaurids rather than the notosaurids. Instead, their tails have keeled armor on the sides. The Antarctopeltas are juveniles, so they feature some rounder and cuter features, as seen in some of the only known complete juvenile ankylosaurs, a squad of Pinacosaurus that lost a battle to the sands. Then, a bombshell paper was dropped in 2021 that totally blasted a hole through these poor ankylosaurs. That was the description of a bizarre, small-bodied ankylosaur from Chile, Stegosaurus. This remarkably complete specimen represents a short, squat ankylosaur with a turtle-like head, long neck, and short, stubby tail that had a series of interlocking and fused, cone-shaped osteoderms that formed a rattle-like club converging on the ancient Mesoamerican obsidian battle axe club, the Macuahuitl. Stegosaurus was not alone, as its very well-preserved features told a brand new chapter in the evolution of the armored dinosaurs. The Ankylosauria group must now be divided into two major groups, the Euankylosauria with all the major forms one might be used to, and the Parankylosauria, which included Stegosaurus but also the Australian Kunbarasaurus and Antarctopelta. In the Stegoros paper, the authors compared it directly with Antarctopelta as they shared the most features and are each other's closest known relatives. If one were to fill in the missing gaps of Antarctopelta with its new relatives, which combined have everything Antarctopelta is missing, a quite different image emerges. Some have gone as far as to reconstruct it with the same battle club as Stegoros. This may be prescient, but most Ankylosaur genera had unique tail clubs. Queenbarasaurus has the most complete skull, so it was used to help fill in the gaps of Stegoros, but those skull bones of Antarctopelta match up quite well with Stegoros, so perhaps they all really did have somewhat similar skulls. No one can account for future discoveries like this, so this depiction may, unfortunately, technically fall under the label of the most inaccurate, but not for lack of trying. Who cares anyway though, the models look stunning and blend right into their natural backgrounds. Behavior. In the Antarctopelta segment, we see that there is a trio of juveniles that stick together and hibernate together over the dark winter months, which are fast approaching. Not that there needed to be that much justification for juveniles to stick together, but the best known juvenile ankylosaur skeletons were found huddled together, having died in their sleep. This death assemblage belongs to the babies of the Mongolian Pinacosaurus and was used as direct evidence for this segment. These little guys are adept diggers, making little burrows that they hibernate in. Though there are no fossilized ankylosaur burrows yet, their forearm and backbone anatomy plus their body shape all suggest the ability to dig and dig rather well. This is the basis for that behavior in Prehistoric Planet. Antarctic Hadrosaur Design. When the hero Antarctopelta strikes out on his own when his usual hibernation den becomes too crowded, he meets a small herd of hadrosaurs. These guys reuse the Edmontosaurus model with a new color scheme. These guys look to have a light gray underbelly and a dark reddish-brown top with some intricate markings of darker and lighter shades. The snouts look a touch longer than the Edmontosaurus model, but I can't really tell too well. The narration leaves these animals as hadrosaurs, as there are not yet any named hadrosaurs known from Antarctica. That being said, their inclusion in this segment is not hypothetical. Ornithopod material was reported in 1991 by J.J. Hooker, A.C. Milner, and S.E.K. Sequeira. This material is a partial skeleton that included a lower jaw, chunks of the upper jaws and skull, neck, back, and hip vertebrae, parts of the forelimbs and hips. The paper that described these remains left their identity as some sort of hypsilophodontid type ornithopod, but considering how fragmentary and weathered the bones were and how much can and has changed in Antarctic paleontology, who knows now. Then, a paper by Judd Case, James Martin, Dan Chaney, Marcelo Reguero, Sergio Marenzi, Sergio Santillano, and Michael Woodburn, published in 2000 through the Journal of Vertebrate Paleontology, described a single dinosaur tooth as that of a hadrosaur. That tooth only tells you that hadrosaurs were present in Antarctica at the very end of the Cretaceous, so what type is entirely unknown. Considering the near-universal distribution of the flat-headed Saurolophine hadrosaurs, it's a good guess that Antarctica had some Edmontosaur-like hadrosaurs. But considering the isolated nature of Antarctica and the weirdness of what has been found already, it's even more likely that whatever was living there at the time was bonkers weird. Still, better for the Prehistoric Planet team to have gone the conservative route. Behavior. They look at our main character, Antarctopelta. What more do you want from me? Pachyrhinosaurus Design. Pachyrhinosaurus is one of only 2 genera of the Ceratopsidae family that didn't have any horns on its head. In place of horns were pads of rectangular bony bosses. Ankylosaurus is the other and the closest relative of Pachyrhinosaurus. The thick-nosed lizard itself was described back in 1950 based on a couple of skulls found in 1945 and 46 in Alberta. Since then, numerous specimens have been found and described, including mass mortality bone beds, 3 species, and even juveniles. The Pachyrhinosaurus that appears in the Ice Worlds episode of Prehistoric Planet is based on the Pachyrhinosaurus peroterum species, which was the most recently named in 2012 and the smallest and endemic to Alaska. The Prehistoric Planet Pachyrhinosaurus is decked out in a bunch of colors and patterns that are all desaturated, so you don't get a good idea of just how colorful they are unless you are looking very closely. They are dark grays, light tans, browns, reds, whites, light grays, plus some brighter reds, oranges, and greens on the face and frill. It seems that the males have the bright green and red splotches on their faces and frills, while the females have red and greenish-white vertical stripes. The juveniles are more boring in color with a light grayish-tan underbelly and reddish-brown top with dark gray stripes and some faint markings on the face. Prehistoric Planet's Pachyrhinosaurus has horizontal ungulate-like pupils as opposed to rounded bird-like ones or the vertical slits of many nocturnal and diurnal predators. More vertically oriented pupil shapes are best for animals that live or hunt close to the ground, as the shape offers them a highly focused field of vision to provide accurate depth and distance perception. These animals also usually hunt at night, so having the vertical slit allows them to narrow the slit during the day to prevent damage from bright light during the day and open up to see more at night. Animals like foxes, house cats, crocs, and geckos typically have this pupil shape. Prey animals typically have horizontal slit pupils that provide a wider field of vision. This gives them an advantage in seeing nearby predators. Although their visual field is larger, their vision is not very sharp, only allowing them to vaguely see the surrounding area. This pupil type can be seen on animals like goats and antelopes, but is also present on all sorts of animals, whether they be prey or predators. Larger predatory animals, like lions and humans, will have circular pupils. These animals hunt higher off the ground and in packs and are generally more intelligent. This shape allows an even focus across the entire visual field, but it also doesn't allow good coping with sudden changes in light, as it cannot constrict as tightly. For those interested, crescent-shaped pupils are typically found in sea creatures like dolphins. This shape allows for a wide visual field and reduces the effects of light distortion by water. These animals can search for both predators and prey with a huge advantage. W-shaped pupils are also found in sea creatures like cuttlefish. These types of pupils likely evolved from horizontally shaped pupils, but they open in darker environments like the deep sea. This shape allows light to enter the eye from many angles and provides excellent acuity underwater and decreases light distortions, similar to crescent-shaped eyes. None of these shapes are directly related to whether an animal eats meat or plants, because there are plenty of both that have every shape I went over, but they often occur in certain animals over others. The shape has much more to do with the animal's lifestyle, which of course can overlap with what stuff the animal eats. So, the Prehistoric Planet team gave their Pachyrhinosaurus horizontal pupils to help differentiate it from the Triceratops and to illustrate a scientific point about the differences in eyes. Perhaps these Pachyrhinosauruses need a wider field of view because they spend more time in open areas than Triceratops. The Pachyrhinosaurs are also decked out in quills on their backs and tails. This is not 100% speculation, as it is based on the presence of a bush of quills on the tail of the very primitive ceratopsian Psittacosaurus. This justification was used for something of a paleoart meme throughout the 2010s that saw plenty of paleoartists give their ceratopsians quilled tail bushes. This even made it onto a bunch of dinosaur figures. The issue here is that Psittacosaurus comes from outside of the Ceratopsidae group that contains all of the traditional horned dinosaurs, was one of the earliest members of the greater Ceratopsia, ran on its hind legs, and carried a frillless but horned head. It would be quite a stretch to think that one tail brush feature would have continued on to the rest of the more advanced ceratopsians when none have yet been found, but skin impressions have, and without quills. That being said, the Prehistoric Planet team's justification was that it cannot be ruled out that ceratopsians would surprise us with the variability in outside coverings. Paleoartist and paleontologist Mark Whitten even speculatively toyed with the idea that the northernmost Pachyrhinosaurus species were covered in shaggy, fur-like feathers to help them insulate against the winter temperatures. Behavior. Dr. Naish made sure to explain that what we see take place in the Ice Worlds episode is not necessarily what these animals dealt with all the time. Both the Pachyrhinosaurus and the Nanuqsaurus were likely more adapted to live in forested environments, not freezing tundra, as in many modern mammals such as mammoths, muskox, and wolves. There still would have been plenty of openings where snow accumulated during the coldest months, with snowy blizzards and temps reaching well below freezing. This is what the team decided to show just to teach viewers that it was possible. How did the giant Pachyrhinosaurus survive in these cold conditions? I mentioned before that some paleoartists toyed with the speculative idea that some may have been covered in shaggy feathers, but this does not look like a possibility, given the fossil data that exists. Dr. Naish points out that these non-insulated dinosaurs may have dealt with the cold with behavior, like taking shelter, migrating to deeper woodlands, and huddling together for body heat. On top of this, based on birds, crocs, reptiles, and convergent mammalian traits, dinosaurs probably had a lot more fat than is often depicted. Their skeletons seem to suggest that they most likely stored their fat in their rear ends, tails, and over their hips, rather than as a thick layer of blubber all over their bodies, but much of this is still up to interpretation. Since dinosaurs definitely did live in the far north, and the far north definitely did see freezing temps and precipitation, the dinosaurs that lived there had to have coped. So perhaps they had more body fat overall to keep them warm than dinosaurs in warmer climates. Captive giant mammals known for living in very warm climates, like rhinos, elephants, and hippos, have all been maintained in outdoor freezing temperatures on occasion. Though not ideal, and bad practice for any long amount of time, it shows that even these animals can endure quite low temperatures. We see a pair of Pachyrhinosaurs shove each other around with their frills and bosses. It has been long hypothesized that ceratopsians used their horns and frills in physical and/or visual intraspecific displays. Some evidence exists in the form of damage to the skull that could only be caused by the horns of another ceratopsian, and the bulk of this evidence is present in the remains of Triceratops. This is no surprise, as it is one of the most well-sampled and well-known ceratopsians. It's not far out to think Pachyrhinosaurus may have done something similar. The last bit of behavior we see the Pachyrhinosaurs do is form a massive circle once they are scared out of the woods and into the open by an approaching pack of Nanuqsaurus. There had been an hypothesis about ceratopsians floated around for a while in the 80s, 90s, and again in the aughts, of ceratopsians forming a ring around the most vulnerable members of the herd so that only the sharp armored heads of the adults faced any attackers, in much the same way that muskox will protect themselves against wolves. It's not a bad hypothesis, except there's no real way to test it. This sort of circle defense is replicated in Prehistoric Planet, but is edited a bit from the muskox in being far looser and more so the herd gathering up for defense rather than a strategic heads and horns out sort of thing. Nanuqsaurus Design. We are now at the final design shown off in the Ice Worlds and North American episodes of Prehistoric Planet, the Nanuqsaurus. This polar tyrannosaur was named and described in 2014 based on an assortment of fragmentary skull material that most closely resembled the more advanced tyrannosaurians, such as the Daspletosaurinae tribe. Heavily built, medium to large-sized predators such as the 3 Daspletosaurus species and Thanatothuristes. The remains of Nanuqsaurus come from the same geologic formation as the small Alaskan Pachyrhinosaurus species, Edmontosaurus, and the Alaskan Troodont. Interestingly, the remains were originally thought to belong to an animal about 5 to 6 meters, 16 to 20 feet in length, and 1,100 to 2,000 pounds. This would make it a miniature tyrannosaur of the north, about half the size of Tyrannosaurus. This sort of goes against Bergman's rule that states that animals tend to get bigger the cooler the climate or closer to the poles they are. Later work based on larger teeth from an older specimen and undescribed skeletal material would put the animal at least at 7 meters, 23 feet in length. This puts it in the same size class as other northern tyrannosaurs, such as Albertosaurus. If they could reach those sizes as adults, then 8 to 9 meters, 26 to 30 feet is not out of the question, and Nanuqsaurus really wasn't a diminutive animal. Prehistoric Planet seems to put their Nanuqsaurus in a middle ground, as they are taller than their Pachyrhinosaurus prey, but are far lighter and more gracile than the other tyrannosaurs in the series. Dr. Naish has noted that the animals they use in the program are still a touch small, so waves it away as them not being fully grown. Let's be honest, that is a perfectly fine explanation as the narration never once mentions their age nor exact dimensions. The show gives them a light off-white underbelly and a dark gray and brownish gray top. They have pleasant orange and brownish orange vertical patches on their faces and across their plumage. One thing that is entirely speculation, but which is also rooted in some hard evidence, is the feathery pelt the Nanuqsaurus carries. They are covered in fluffy, simple feathers from the top and back of the head to the end of the tail, the arms, and the thighs. No Tyrannosaurs have ever been preserved with feather impressions, but something that was only a touch smaller than Nanuqsaurus that was related to it was preserved with feathers: Eutyrannus. Eutyrannus is a Proceratosaurid, which still belongs to the greater Tyrannosauroid group that Nanuqsaurus and every other Tyrannosaur belongs to. Eutyrannus reached about 30 feet in length, and its fossils have feather impressions. It's technically the largest extinct animal preserved with feathers. If something like this critter could be that big and have feathers and be a Tyrannosauroid and lived in cool climates, then it is highly likely that Nanuqsaurus did as well, and that is the hypothesis illustrated here in Prehistoric Planet. There have been some small patches of skin impressions from Tyrannosaurus, Tarbosaurus, Albertosaurus, Thespletosaurus, and Gorgosaurus, but all of them are in places that do not necessarily negate the presence of some form of other integumentary structures, such as fine hair-like feathers in the big forms, or those forms that lived in warm climates, or dinofuzz in the colder climate forms. Both feathers and the type of scales seen in Tyrannosaurs can coexist on the same animal. There is even direct evidence in modern birds that feathers might sometimes erupt directly out of scales, though I wouldn't pin any hypotheses on that. Crazy side note, the scales on the feet or legs of living birds may even be modified feathers, rather than being the same scale structures seen in non-avian dinosaurs. The one thing I have and continue to find odd about the theropod dinosaurs in this show is that their elaborate keratin crests and ridges on their heads are always so drab. The majority of the keratinous crests of modern dinosaurs tend to have some color to them. The obvious exception is everyone's favorite dinosaur reference, the cassowary. So, I'm not saying that every single dinosaur with keratinous crests had to have bright colors on them, but it would have been aesthetically pleasing to see some variety in that department personally. We do see some blues on the Olorotitan's crest. I quite like that. One could easily excuse the boring theropod horns by the animals being outside of breeding season or something. Super minor nitpick on my part specifically. Behavior. The Nanuqsaurus pack flush out the Pachyrhinosaurus herd from the woods and into the open as a blizzard begins. Not much can be said here for behavior as they are not shown having coordinated wolf-like hunting strategies. This is an unlikely behavior for any dinosaur to have anyway. The Nanuqsaurus and the herd have to take a break from life and death to wait out the blizzard, and then they resume, successfully isolating and taking down an old bull Pachyrhinosaurus. The science used for this show is groundbreaking. The speculative nature of a lot of the stuff shown is equal parts necessary and representative of the real world. Two of the main consultants, Drs. Mark Whitten and Darren Naish, helped to bring forth the modern dinosaur renaissance with their little paperback landmark book, All Yesterdays. I've made a two-part series of their work here on Edge that you can view to get a really good idea of the kinds of visions that team was trying to convey. With their work, they were not trying to say that speculation should be taken as gospel, or that those who cautioned conservativeness in reconstructing long-dead animals are wrong. Instead, their intention was to show the world that the animals of the past are as the animals of today: gross, complex, and alive. The world around us has only been around us for 1 to 2 million years. Before us, the modern paradigm has been around for 66 million years. Before that, there was an unfathomable expanse of time, 184 million years of time. If I wanted to really scramble your brain, there is an even more unfathomable expanse of time before that. But we're talking dinosaurs right now. For as alien as certain parts of the Mesozoic era may seem, the laws of nature retained their stranglehold. Animals of the Mesozoic had a much longer period of time to get gross and complex, so to think so narrowly as to only reconstruct the animals of the past as closely as their bones can say is to completely ignore everything we know about life. In fact, because of the much longer period of time that the dinosaurs had, it is nearly mathematically impossible to think they didn't get into weirder stuff than we see today. This seems to have been the driving force behind Prehistoric Planet, at least with the consultants and animators. I mean, we all know Favreau just wanted them to act like animals and look pretty. No shame or shade there. So, what did you think of Prehistoric Planet? This video is way too hefty to only now get into the music, cinematography, and directing, or my criticisms therein. I have just gone through every single aspect regarding the science behind this show based on the very sparse information we have right now. Darren's tweets and the uncovered segments can only tell us so much. I think I can speak for everyone that we are eagerly awaiting a behind-the-scenes documentary on the documentary. In the meantime, we can only imagine. I do apologize for not getting to the rest of the series until the near premiere of Season 2. But it is what it is. At least it might get you to relook at Season 1 before we get more goodies. For more interesting stories about nature, the history of life, or what goes bump in the night, subscribe, like this video, drop a comment in the comment section below, and hit the bell icon to stay in the know with everything Edge. Thanks for watching.